Hello, friends of the Butterfly. I know we haven't looked into Butterfly CFD for quite a while, and a lot of people asking me, hey, can you do more videos about Butterfly CFD and that topic? And yes, certainly I can and I will today. For that, I created this very cute little toy model, and this will become our test object because I thought it would be really good to look into a more complex object rather than just boxes, which we didn't have done in the past, and we will learn way more about how to mesh and how to use the block mesh and the snappy hex mesh to really understand how that process works. And then the follow-up videos. So let's see how many videos that needs. But then the follow-up videos will be more about the other tools within Butterfly CFD. For example, the indoor airflow and heat transfer. Before we jump in, I want to give you a sort of a warning. Butterfly CFD was developed until 2019 and for some reason stopped, or it just paused, and there was no update since then. And it's still a work in progress. So there are tools within Butterfly which don't work yet, and it's very buggy. It has a lot of bugs. So that's an issue especially for people who try it the first time and they run into issues and think it's their fault, but actually it's the software's fault. So that makes the whole thing a bit more difficult. That doesn't mean that you cannot use it. It's actually, you can run real simulations because you have the Blue CFD, which is the Windows version of the OpenFOAM engine in the background, which of course works. So that's so far to Butterfly, and it's even for me sometimes difficult on to guess what is now my problem, or was it the problem of the software. So that's a bit of a trial and error. Installation, very important. Please, if you want Butterfly to run on your computer, you need to follow the installation. You can go into one of my. So I did a video in the past, the first video in this series, or in this playlist, let's say, the CFD in Rhino3D and Grasshopper3D. The first video I did was about the step-by-step installation, and you need to follow it on the dot, otherwise it will not work. You need to run your Rhino in admin mode. This is a must if you want to run Butterfly on your computer. You need to install the right Blue CFD version, which is the 2017 version. There are two versions for 2017. Both should work. I'm using the later one, so I recommend you install that. Any other later version of Blue CFD doesn't work with this version of Butterfly. You need to create an environment. This is part of the installation instruction for Blue CFD. It's also in that video. And finally, which I haven't discussed, which I didn't said in the past, please make sure that your unit system you're using in Rhino is meter. Everything in this CFD visualization calculation is done in meter. So if your unit system is millimeter, you will run into problems. Or if you use any other unit system, you will run into problems. Wind speed is meter per second. Pressure is is Pascal per square meter, and so on. It's always meter. You just make sure you understand that. And now, without further ado, we can jump into the plane model CFD test. I have here like a new window, and we go from here. My model is, I have a plane here on the bottom just to create a distance from the ground. Otherwise, the tunnel will always be created on the bottom of the object. That's why I have this plane here. And then I have my toy plane here, which is a mesh model. And it's a closed mesh model, and I will recommend that your model or models or objects are all closed or solids. That they don't have to be meshes, but they so you can use any solids, or you can use B-wraps and so on. closed poly surfaces also work. They will be translated into meshes during the setup. And then we have Butterfly, and you can already see this looks so intimidating. When I first saw this objects here, I thought like, oh my god, no, forget it. I closed it right away because I don't know. I will put here the bifocals because these are super useful for you, so you know exactly what tool I'm using. And we will go very quickly through the basic setup, and then I guess in the next video we will refine the setup. Okay, so very quickly. First tool we don't need, this is updating Butterfly. Since there's no update, we don't need it. This tool is to rerun a case which is already written to a folder on your computer. We don't have that yet, that's why we don't need it. What else is in here? Create butterfly geometry, that's what we need for sure. So the plane is a mesh, here, mesh. And you know, again, I can't say it enough, anything with an underscore at the front is mandatory, and if it's on both sides, it's optional. If it's at the end, it's even less relevant. But we will see that there are mistakes made by the developers where they forgot this system. Another thing to keep in mind. Yeah, it's very buggy. I need to give it a name. This is mandatory. Name is mandatory, otherwise it doesn't work. It can't be. You cannot have a space in between, and you can only use certain special characters, like underscore, for example. That's possible. Boundary, we don't need that for now because this is not an urban. It's not a building. We don't have walls really. We could set it as a wall. This is the most closest we can probably get to. If you see here, there's a boundary types is inlet flow rate boundary, outlet boundary, wall boundary, and custom boundary. I have looked into the custom boundary, and for me it's very cryptic. I hope I can learn at some point really what that all means. And then we have some boundary conditions. This is also very. It's nowhere really good explained what that is, but in our case, I think it's fine when we use this, and we could say it's a wall, but since we don't need to provide anything here, I will leave it for now, and we can test later if it makes a difference. I place my mesh here, and I also need a surface. I had it already. And to plug this in, you can mix and match. That's very good. So now I have my name, I have my model, my two objects here, and that's more or less it. Mesh setting is the mesh setting from Rhino. You can use the same as it is here, like you can use mesh preview quality. You know, there's low, high, and mid in custom quality and so on. It's very similar to this one here. There is ways to create your mesh out of this objects. Since my plane is already a mesh, I'm not using any of these. It's like optional, but you could set like a high quality or a more jagged, faster mesh option. I don't think it matters. We can use that here maybe. Let's see how that will change. I don't think it will have much influence really. So that's our geometry. Can group that together and name it geometry. So what else do we have here? Create butterfly geometry. Yes, we did that. Butterfly create case from geometry. This is for, let's say, indoor flow, for example, indoor airflow. Butterfly create case from tunnel. That's what we need. So we can put this in here. We also need a name again. And we call it case. Again, underscore, you don't forget that. And then you can see we need a wind vector. This is also mandatory. It's better to show it here because you can then see where it is. We have wind tunnel parameters and we have wind vector. The wind vector goes here, wind speed What could that be? Let's say 20. It's a very slow plane. Doesn't matter for now. Wind direction, it's funny, here's a wind direction, but don't use it. Rather rotate your model. This doesn't work. It has a lot of issues. It always might work, but then it might not, and so on. So I would not use that. You can of course try. And if you find a solution, perfect. We can set the landscape. In that case, that would be 0. Here set to it's set to 6, which is kind of an urban, suburban kind of context. Since we're not in the city here, I will say it's 0, so meaning no obstacles. That might influence your wind speed. And the wind reference height is 10. I will not change anything here because I have my wind speed. I have my basically assume that this object is moving and it has its speed. So, and then we have tunnel parameters. You can go here, back here. Tunnel parameters. This is basically a way to control the size of your tunnel. But now, just to explain this a bit better, I need to first run this case here so you can see it actually. So I ran my case, that's fine, and we can look at it. We can look at the output. Oh no, sorry, it's actually already here. You can see it. You can see these like these 8 points which are arranged to create a box, and that's my case, and that's the size of the wind tunnel. And I can change that by making it smaller, because at the moment it's really big because of the plane on the ground, and I want to limit that a bit. So I can set a value here, let's say 2. Currently what is set here is 3. Maybe let's make it even smaller. I set 1 for windward and leeward. Now you saw that this moved further to the plane, to the toy plane. Can do the same with leeward. Maybe that's a bit too much. Let's use 2 here. And I would use integers here. I just ran into issues with that. It's very interesting. Maybe 3, that's good. And here we are using, for the top, it's currently 5. Maybe let's try 2. 2 looks good, promising. And sides we also use 2. Let's use 1. Let's see. Let's try 1. So now we control the size of our test. Otherwise, it creates a lot of cells, and the test takes longer. And we also have here the make 2D parameters. That's if you want to have like a test in a 2D plane, not to confuse it with the probe points plane, which we put later on. So the probe points can be also just a 2D plane, but they can also be a 3D grid. Let's check that where it is. It's this one. I prepared it already, so it's just a surface where I'm gonna place my probe points later, and they can be arranged in any shape, any way. And there's a way to make this 2D from the get-go, but we can look at that another time, because we want to actually look at the output not just in Rhino but also in ParaView later on. So let's do this first, and we'll see how that works. So here you can see there's the boundary. We're actually done here. There's not much more. There's other things which we might need or can look at later, but then again, some of these tools actually don't work. The refinement region, I was not very successful with that to make that work. It didn't really change anything. So some things are just not ready, but it doesn't matter because you can still run a very, very good analysis. And we can look at the case later on in ParaView even more in detail. This is because Butterfly is just an interface really for the Blue Core CFD, which runs in the background. Okay, now what we need the block mesh. Here's just very simple. We need the case. The name of our case is toy plane case. And we need a write and a run, a toggle for a write and run. Need to set this to true and then run so it runs. And now we can, so what that does, the block mesh, it divides your tunnel into cells and in equal cells in that case. And we can look at it with this tool. I never tried this actually, load points. Let's try both. Load mesh, so that's what we need here. We can use the case, put it here, and we also need to set this to true, and we can see what it did. So create a very rough, create cells, and then if you use the inner mesh, you actually see that these are really cells. It doesn't yet see your mesh really, your object inside. And also the mesh is very large. So let's put this here. I never looked at this, the points. I'm curious how that looks like. Oh, case. Put the case here. Interesting. Okay, these are the corner points of the cells. Interesting. Okay, we don't need that really. Just want to be a bit more careful here. The case. Or maybe let's combine this later, so it's the wind tunnel. And in order to grade, so that you can see here there's grade X, Y, Z and cell count. And we want to apply grading to the cells, so they're not all the same. They are actually smaller around the object we're testing and larger towards the outside. And we can do that by using this load mesh. We can use this wind tunnel grading. Wind tunnel grading. That's the thing we need. That tool needs the wind tunnel as an input, and it has these outputs here. A report. Let's see what the report says. That's fine. That works. By the way, I tried here to use float numbers. It works sometimes, and sometimes it doesn't work. It creates weird error messages here, and it sometimes doesn't work, and sometimes it works. But so if I don't need to actually add anything else for now, just to show you how that looks like, we can directly plug this in here, and the cell count will go here. And of course, let's get rid of this because it's so now you can see that it applied a grading onto this grid, so it becomes more finer towards around the model and then larger outside. And we can control that here with this one. First of all, the cell size, we can control the cell size, which we need to in order to refine that whole thing later. So for example, we could say the cell size is not 1 meter, it's half a meter. It becomes much more finer. And then we can also set the ratio on how strong it's gonna grade. So I think the default is 1.2, and we want to set it maybe larger so it grades stronger. So that means that these cells outside are much larger because we're not looking at this data anyway, so we don't need that. We don't need that information that much. So basically we created our wind tunnel and we divided, we created our block mesh. It's a block mesh. We don't want to always look at it. So we hide this again. I would say this is still part of the wind tunnel, so we can combine these as a group and call this the wind tunnel. Now, okay, next step in the whole process is the Snappy Hex Mesh. And here it becomes interesting because we haven't looked into complex geometry. I mean, if you called it complex. Definitely more complex than the box. Put the case in here. We again need to run and write this. So we can set this to true. And then we also can run it. That was quick. We can again use the same thing. Oh. It's still a mesh, so it's created a mesh. But let's have a look how that looks like. The case goes here. This needs to be set to true, and then we can enable it, and we see, now it created some kind of shape around this toy plane. Let's hide this one. And you can see, if I hide this here, it's actually a very bad, it doesn't really do much here. If I hide the geometry here, you can see let's not hide this. That's what's currently trying to approximate. Looks more like a sausage. So there are two parameters we can use in order to refine that. One is the cell size. This is the one here. And the refinement, global refinement levels. And there are other things you can use to play with the mesh, which is within the Snappy Hex Mesh Dictionary. To be fair, it didn't really do much for my model. I mean, we can open it. Oh, that's not what I want. Snappy Hex Mesh Dictionary. He can set the mesh quality, the castellated mesh is all set to true already. There's not so really much in there which helps, and some items actually don't work. So for now, I really don't need that. It maybe has some interesting features, but for the test, I don't really need it. Location in the mesh, another feature which hasn't changed anything when I used it. So I would say forget it. The global refinement level, this is important. That's the most important setting here. And we can just place this here. And we need to provide two numbers. One is the minimum and the maximum. Again, it doesn't really, if I, for example, set this to 1 and 4, it doesn't change much in terms of if I set it 1 to 1, but it still needs to be 2. But we can test it, let's see. Global refinement levels, if I put this here, it recalculates. It's a bit better, it's slightly better. That looks more like the plane, but there's no, you can't see any details on the windows. And still a lot of stuff missing. We can set 2 and 2, and then it becomes also slower to calculate. Yeah, looks much more like the model. There's still like very weird artifacts. Maybe let's have a display. No. Custom preview. Let's do this. Yeah, there's still, as you can see, there's still stuff missing. Let's set the material here so we can play with the transparency. I thought I might see the lines through, but it doesn't. It's still not there. You can already see it starts to really shape it along the details, but it's not there yet. So we could set this smaller, of course. We can make the hex mesh smaller. That also has an influence. So the block mesh. We make the block mesh finer. That already will have some influence on the snappy hex mesh as well. But again, yeah, of course now it takes longer, yeah, to calculate everything. Still not there really. So we can, normally I would then go up to, let's say 3 or 4. And I'm gonna show you that this doesn't really matter that much if I use 2 and 4. Well, let's try. Maybe it didn't just work before, now it works. See, it didn't change anything, although it says set the minimum and maximum. So it's weird. So if I now set 4 and 4, so if I would set 3 and 4, it would be same as setting just 3 and 3. But you cannot set just 3 either. That also doesn't work. So it's a bit strange. So yeah, I'm setting 4 and 4, and then you see how that looks like. Yeah, that took considerable longer, and you can see this now. It's much finer. This whole mesh, and now we can also see some details, more details here. So makes definitely more sense, I think. Now it's almost a bit too much. It took really long, but that's how you can refine your snappy hex mesh. And of course you can try to play with these values, and probably also the cell size. It might be that 3 as a global refinement levels is okay, so we don't need to go lower. I encourage you to also play with the Snappy Hex Dictionary. In order to set up the solution, we go back to, let's say, 2 or 3 maximum, just to set just to make the solution work first, and then we can increase again to make a more finer kind of test. In the next video, so we're gonna look into how to run the solution, how to set up the prop points, and how to visualize. And then we also might look into ParaView, so you get the ultimate feeling on what's actually going on. Because what you can see in Rhino is just half of the story. ParaView has more tools where you can actually look at the data in much more interesting ways, like with flow lines. There's even an option to animate things, but I'm not sure how that exactly works yet. But yeah, that's all upcoming. See you in the next video.